everyone. Today we're going to start section 4, which is about the outer solar system. Remember, in the last few lessons, we've been learning about the inner solar system. So, the inner solar system are Mercury, Venus, Earth, and Mars. These four are collectively known as the terrestrial planets because they tend to be a lot of Earth like. They have a crust, mantle, and core, they have a hard, rocky surface. These planets tend to be warmer, but they tend to be smaller because of their proximity to the sun. And then also a couple other characteristics about them include that they don't have any rings and that they do not have any moons, or if they do, it's only one or two. Today we're going to learn about the outer solar system, and they're collectively called the gas giants. We're going to introduce you to them with this false colored image taken by the Hubble Space Telescope of the planet Uranus. It was discovered in 1781, and here you can see that it has rings around it. And the rings actually were not discovered until 1977, and both of them were discovered by accident. So that's a good gateway into what we're going to be talking about. Our key question that we're going to be answering are, how are gas giants similar? So the first thing that we're going to need to answer, what are gas giants? What planets count as gas giants? And then going over these similarities. So a few that we're going to talk about is that they all have small dense cores and they all have thick atmospheres. And these atmospheres are mostly made up of hydrogen and helium. So like I've stated, we're going to be going over all four of these. Today we're going to cover Jupiter and Saturn, and then in the next lesson we're going to cover Uranus and Neptune. These four are very different from our terrestrial planets. Typically they're going to be much colder, and that's just because they are farther away from the sun. All four of these planets are larger and more massive than the terrestrial or inner solar system planets. And they are all called gas giants because they are mostly made up of the two main gases, hydrogen and helium. Now, one thing to note is that these are called gas giants and none of them have solid surfaces. They're not terrestrial. In fact, if you tried to land a spaceship on one, you would sink into the planet and eventually the pressure would get so high or so strong that it would crush the ship. So we haven't really sent any rovers out there to land on these planets. We've just been sending out space probes to kind of rotate around the planet and get pictures and test data. In fact, that pressure is actually so strong that the entire planet is not actually all gas like they make you believe. A big chunk of the hydrogen and helium actually exists in a liquid form. Another cool thing about gas giants is that they actually have moons, and they can have a lot of moons. Jupiter has over 63 moons, and they all tend to revolve in the same direction that the planet rotates. So if the planet rotates clockwise, the moons are also going to rotate clockwise. Another key attribute is that all the gas giants have rings. And most people don't realize this because they only think of Saturn when they think of the major beautiful rings, but each and every single one of them have them. In case you were curious, a ring is a disk made up of small particles of rock and ice, and they orbit around a planet. And that's one of the key distinctions between this definition and the definition that we're going to be learning about comets. Comets are also described as chunks of rock and ice, but the key difference is comets do not orbit around a planet, rings do. Now, why do planets have rings? Well, the reason they have rings is because they're so massive that their gravitational force is large enough to prevent these ring particles from clumping together to form moons, but instead what they do is they rotate around that planet. Here is a little diagram that shows the outer planets, and down here they have listed Neptune, but there's a little asterisk next to it, and it says down here it's just included for comparison. Pluto actually isn't a planet. It was reclassified as a dwarf planet in 2006, which sparked a lot of debates. So from this little slide, I want to show you just how big these planets are. So 142,984 kilometers is just the diameter of Jupiter. And as you can note, it's one of the absolute largest planets. If we look over here, there are two columns, and I kind of want to talk about these columns. Rotation. Anytime you hear about a rotation, we always talk about this in terms of days. So, how many times or how long does it take a planet to spin on its axis? So, if you think of a little top toy or like a coin and you spin it on the table, one time around would be considered a day or a rotation. A revolution is different. This counts as a year. So this is how long around the sun. So this is around the sun. One thing I want you to note about these is that planets actually spin very fast and their day is actually shorter. But if we look at their year is extremely long. In fact, 11.9 years pass here on Earth before 1 year passes on Jupiter. And the last column is the number of moons. So as you can see that a lot of these gas giants tend to have a lot of moons. So again, like I've stated, we're going to focus on Jupiter and Saturn today and then talk about Uranus and Neptune tomorrow. So what is a characteristic of Jupiter? The most obvious one that most people jump to is Jupiter is the largest and most massive planet in our solar system. When we talk about Jupiter's atmosphere, remember all of the gas giants have thick atmospheres, but Jupiter's tends to rotate pretty rapidly. One day on Jupiter is less than 10 Earth hours. So these clouds are moving very, very quickly. And if you've ever seen pictures of Jupiter, they appear to be two different colors. And this coloring comes from what other gases are mixed in with that hydrogen and helium. Some of the clouds tend to be brown. These are going to be colder and they move faster. The white bands tend to be warmer and these are going to move a lot slower. However, when these two bands actually meet at a boundary, they have the potential to produce storms. It's kind of like if you have a warm front and then a cold front moves in, they're always worried about tornadoes coming out. For example, a big, huge storm that we can actually see on Jupiter's surface is called the Great Red Spot. And I'm going to go ahead and underline that. And I feel like that's something you should know for your test. The Great Red Spot was caused when these two different colored bands blowing in opposite directions caught each other and it caused them to start rotating around like a hurricane, and it created this big storm. It was first observed in 1664, but it could actually be a lot older. So here's a picture of Jupiter and the imaging of the brown versus white bands. So again, this is going to be them clouds moving around Jupiter. And then right here is our Great Red Spot where a big storm is going on. This is taken by Voyager 1. And this giant storm is so big that it's actually larger than Earth. In terms of Jupiter's moons, Jupiter has at least 63 and more are being discovered. If you go to NASA's website, they can tell you about Jupiter's moons and how many it currently has at this point. One thing to note is that most of those are small, less than 200 kilometers in diameter. Ganymede and Callisto are actually the biggest moons that Jupiter has, and they're about the size of Mercury. The next two down are Io and Europa. These are somewhat smaller, but not much. They're about the size of our moon. And then a fun fact is Io is covered in erupting volcanoes. So on the next slide, I'm going to be talking about these Jupiter's moons. I'm not going to ask them on your knowledge check quiz, but you are going to see them on your homework. So speaking of each of these, Ganymede, Io, and Europa have metal cores and rocky mantles. And Io is actually covered with actively erupting volcanoes. So Io tends to be very warm or very hot because of these volcanoes. Ganymede, Europa, and Callisto are the opposite. These three are all relatively cool and covered in ice. And a fun fact about Europa is that the ice that it has appears to sit or cover over a liquid saltwater ocean. And because water is the foundation of all life, a lot of scientists believe that Europa could be another place in our solar system that was able to or could have the potential to support life other than Earth. So here are the two pictures of two of them. Io, this shows that it has a lot of volcanoes, and we know this because we've tested it and seen that there's a lot of sulfur. And then Europa may have a liquid ocean beneath it. And here is an image where we see a lot of dark fracture lines in the crust. The next planet out from our sun is going to be Saturn. So a characteristic of Saturn are the rings. These are the largest and most visible rings from Earth. Another fun fact is Saturn is the second largest planet in our solar system. When we talk about its rings, they are made up of ice or ice-coated rock. These particles can be as small as a dust flake for a few micrometers or as big as big, huge rocks of 10 meters, but most of them are about a baseball or softball size. The rings are about 274,000 kilometers in diameter because they have to be able to go around the whole planet, but they're only tens of meters thick, so not terribly thick as you may think. In terms of Saturn's atmosphere, one thing to know about the outer solar system planets is you're going to hear that their atmosphere is pretty coloring or it has winds or storms. And this is true for most of them. Saturn has a colorful banding in its atmosphere, and the banding is slightly different because it does have different elements. And because different elements make up the atmosphere, Saturn actually has the lowest average density for its atmosphere. It is, again, like I said, mostly made up of hydrogen and helium still. There are just small amounts of other elements as well. So here is a picture of Saturn. It has a very thick atmosphere. It's surrounded by a huge thing of rings, and it is the second largest in our solar system, but the largest rings. In terms of moons, astronomers had found at least 56 moons around Saturn. All of them are relatively small, but there is one of importance, and its name is Titan. It's larger than Mercury, which is our closest planet to the sun, and Titan is actually the only moon that has a thick atmosphere, or it's big enough to bring in gas particles to create this atmosphere. And that's the end of that section. So if you have any questions, please reach out and ask. And otherwise, I hope you guys have a great day.